In the immune system, you have two types, innate and adaptive. In the innate, you have the natural killer cells, which will attack cells that don't present MHC1. So if a cell becomes infected, it'll stop showing the MHC1 major histone complex 1, and then natural killer cells will kill that cell. Mm, you also have macrophages, and macrophages contain lysosomes, which will break down anything they endocytose, and then macrophages are actual professional antigen progenic cells. And complements are also used to poke holes in bacteria to screw up their osmo regularity balance. Um, so MHC1 is endogenous and it's present in all cells, and MHC2 is only professional antigen presenting cells. MHC2 activates the CD4, which is the helper T cells, and MHC1 activates CD8 killer T cells. The adaptive immune system is more specific. So it's triggered by the helper T cell, which will activate cytotoxic T cells, which will kill which will kill viruses that have infected cells, and the cells lack MHC1 complex. This is a cell-mediated response. However, you have the humoral response, which you have B cells that produce antibodies, and the antibodies will be circulating in the bloodstream looking for any antigens that are complementary to the antibodies. B cells also produce memory cells, which cause a quicker immune response. Some of the organs in the immune system. So you've got the bone marrow, thymus, and you've got, this is also just a side, leukocytes, which are blood cells. Bone marrow produce B cells, and thymus is where the T cells positively mature, which means they avoid autoimmune. Anything that's negatively selected, that means that it's going to be apoptosis will be induced so that it dies and it won't attack your own cells. MHC1 versus 2. MHC1 is in all cells. It's presented to the cytotoxic CD8 cytotoxic virus killing cells, alerts the cytotoxic C cells. MHC2 is an exogenous antigen that helps to helper T cell CD4. This is going to alert the helper cells, which is also CD4. Antibodies. So passive immunization is through the milk, the mother's milk, and the placenta. But these antibodies don't last very long. Antibodies mark pathogens for degradation by macrophages. They will there's multiple binding sites to the antibody, so you have agglutination, which is clumping of pathogens, which is easier for a macrophage to pick them up. And you have antibodies that bind that prevent viruses or other pathogens from binding to cells and reproducing. Helper T cells, there's two lymphokines, and there's Th1, which is secretion of interferon, which activates the macrophages. Th2 activates the B cells, which is primary in parasitic infections. Granulocytes, you've got neutrophils, eosinophils, and basophils. Neutrophils will neutralize bacteria. Xenophils will kill foreign parasites, and basophils are for allergies. B cells mature in the bone marrow and have specificity, but antibodies respond at a given antigen, undergo hypermutation or rapid mutation of the antigen binding sites. Only the B cells that have the highest affinity survive and proliferate. This is clonal selection. And finally, memory cells are used to carry out a much rapid and robust secondary response. This is why vaccinations work.